Hello everybody. I hope you can hear me loud and clear. First thing first, I would like to thank the Confidence Committee for choosing my talk and of course for still having this virtual conference. My name is Omer Tsafarti and I am a security researcher at CyberArk Labs. My recent researches were focused on cloud security and on the authentication mechanism. And I've been chosen also to be one of the MSRC most valuable security researchers for years 2019 and 2020. Right, let's begin with our presentation. And today I will show you two critical vulnerabilities that I found in Microsoft Online Services. Those vulnerabilities affected millions of users and potentially could lead to mass account takeover if the bad guys found them before we did. I'll briefly speak about Azure and its features, and including its integration with on-premises environment, as known as hybrid environment. Then we will cover the first vulnerability for today, the manifest vulnerability. A vulnerability relates to misconfiguration that was in Azure Portal extension manifest that eventually could let a malicious attacker to take over a victim's account. And right after it, we will understand the fundamentals of the authentication protocol OAuth. And of course, when you're talking about OAuth, you must also speak about OpenID Connect or OIDC in short. And moreover, we'll talk about an OAuth configuration related vulnerability in the second part. It's a vulnerability that we found in Microsoft that affected all Microsoft 365 users, including all the users created in Azure Active Directory, even if you didn't have a 365 subscription. And we'll see how a simple leak of monitoring brought up to light a dangerous account takeover vulnerability. And at the very end, we'll talk about how you can mitigate those vulnerabilities. And right after it, we'll have some time for Q&A. All right, so Microsoft Azure. Microsoft Azure is one of the rising stars of the cloud computing services providers of this time, and also a tech leader in this area. Considering the 4-year gaps Microsoft has compared to AWS, which launched in 2006, and Azure, which launched in 2010, it is impressive to see how Azure closed the gap. Azure today offers more than 600 services, and it actually increases daily, regularly. One of the primary key advantages Azure has compared to its main competitors, it's the excellent integration with on-premises Active Directory. And as you know, guys, every good platform needs a good controlling panel. This is the Azure Portal, which is an all-in-one controlling panel that Microsoft offers in order to manage your cloud assets in Azure. In one of my researches, I happened to look at some Azure features, and while looking at the outcome traffic, I identified some bizarre requests. I saw those requests, telemetry ones, were sent to strange host, a local host called URI Hubs. Which was really odd. So those are the requests. At first glance, I thought that was just a bug, something that I did to my browser, just a random black magic that happened to visit me from time to time. So I refreshed the page and closed and opened my browser, restart my computer, and even went to another computer, and I still saw those strange requests to the local server. And I also changed an account to another account, and just the same request went out. So let's see the raw request. So let's take a look on this request. It's a bit weird. Why would Azure send those requests? It's weird, doesn't it? And if you take a closer look, we can see the host is URI Hubs. So I searched for the string URI Hubs in the capture traffic to see what triggered this. But I couldn't find any results beside a few files that the URI Hubs string was in it. And one of those files was the configuration file, which is the extension manifest file. The configuration file is located at portalazure.com/content/extension manifest/the current version.json. So you may ask yourself, what is extension manifest? So every extension in Azure located in a JSON manifest file that defines basic information about the extension. We can see in this picture the app extension as a URI attribute that contains the Azure apps string. If we take a look on the other extensions, we can see clearly that those who has URI attribute, their URI attribute is not like the one we have. Well, that's interesting, doesn't it? So we know it is something that is connected to the extension manifest. And another thing to say about extension manifest is that every, if not all the pages we see in Azure is actually an extension that we browse to. So that's a great starting point to understand the issue itself. So in order to understand better what triggered this request to go out, we set a xhr/fetch breakpoint in Chrome Developer Tools. So the breakpoint will break on every request that contains the URI app string in it. So very shortly after the breakpoint set, it triggered, and we could analyze the function that triggers that, and which one is passing the URI attribute of the extension. So we found out this is the one. It's an obfuscated function named TT. At first glance, can you see what could be a problem in this function, the parsing problem? Well, it is a bit hard, at least for me. So let's see what happens when the function actually called with a relevant parameter. So it looks like that. And now it actually looks better, I think. So we can see the result function returns an object, which include origin, protocol, and href. And we could also see that the origin is malformed, and also it's just the same host that we saw in the strange request before. Well, that's interesting. So I really hate obfuscated functions, and to make things a bit clearer for me, I rewrote this obfuscated function so we could understand it better. So this is the one that I wrote that does just the same logic. So the function get URI object receives a string, which is the URI that needs to be parsed. The function looks for the location of the first double slash. And if it finds it, it sets a flag variable called isURI contains /. So in short, it looks for the double /s in the URI parameter that pass to the function. Then if the URI string contains those /s, the function will take everything that is before that and consider it as the protocol that need to be used when sending a request out using this URI. If the URI string doesn't contain the 2 slashes, the script takes the current page protocol and set the value and set it as the protocol value. Right after it, it searches for the location of the single slash index after the 2 slashes. Then if there is no single slash, it will search for the question mark, which in our case, there is a single slash. So we want to search for the question mark. And right after it, it tries to extract the origin that it should be sent to, or the domain name. So as you can see, it tries to get it will go to 2 characters after the / location index. In our case, the index is zeroed by the function because it couldn't find the 2 / in the URI parameter. So it will take everything from the index 2 until the index 9, which is the one that before the slash, the single /. And then the function wraps up everything into an object and returns it. And that's about what we got eventually. So now we understand the bad parsing part and what really went wrong there. So instead of parsing a URI as a relative path, as it should in this case, it parses it as a regular URI or URL. All right, so with that understanding in mind, let's figure out what can go wrong with those requests and what is going on there. So we can see this is an option request. And option requests are made in order to verify a destination is ready to talk with us and accept the request method we would like to use. In case everything is okay, the browser will then send a real request that he intended to send at the first place. So the request in our case looks like this, and it contains a very interesting header, which is the authorization header, of course. The authorization header contains a valid access token to Azure Resource Manager API, and which you can actually use to control almost all the resources in Azure, of course, according to the user's permission. So that's interesting. If I was an attacker, I would like to put my hands on this token, of course. So if we will consider the attack scenario, it will look like this. The user is browsing into the Azure portal. The bug in the portal sends the token to the URI hub's host, which the attacker owns in some way, and we'll talk about it in a second, how it can be happen. And then the token is sent to the attacker. Now, after the attacker has access to the token, he can impersonate the victim and take action on his behalf. So in theory, that sounds good, but can it really be exploited in real life? That's a good question. So yes, indeed, it can be exploited. This attack scenario is real and can be exploited in both local environment and a regular environment. All right, so the first attack vector is the local environment scenario, which in it, the attacker spin up an host in the network, in the local network, and calls it URI hubs. Then it gets a signed certificate by a root CA or by a local domain root CA. And after setting this all up, whenever a user will browse to the Azure portal, it will be affected by the bug and send his token to the attacker. But this local environment attack, well, it's not that interesting. We thought it will be much more interesting if this attack could affect every Azure user out there in the world. Does not matter where it's located. So it actually can be done. And the main reason for this is DNS servers configuration. DNS servers most of the time do their job well, but some DNS servers may actually do it too well. And let me explain what I mean by that. Some DNS servers configurations add a suffix from the commonly known top-level domain like com, net, org, and etc. And they add it to the local host names when they don't manage to, when they can't manage to find the recorded their host name in the local record. In this case, the DNS server, when it's trying to resolve URI hubs, it's also trying to resolve URIHubs.com, URIHubs.net, etc. So a potential attacker can abuse this behavior by registering many different URI hubs domains with different suffixes and exploit them. So yes, it won't actually be enough, as the attacker still needs a valid certificate for the local server sign up by a public root CA. And as of November 1st, 2015, CA/browser forum no longer allows publicly trusted SSL certificates to include those local names, such as internal server names and reserved IP addresses, as it could lead to man-in-the-middle attacks in local networks. But there are still malicious root CAs, and some root CAs that have been compromised over the years, like Comodo in 2011 and DigiNotar in 2013, for example. So it actually still can be happen, this kind of attacks. So for making a POC out of this, we bought 27 different URI hubs domains with different suffixes, like URIHubs.com, URIHubs.net, org, and etc. And of course, it was as a responsible and a protective measure, of course. Another important point to make that security features are great. Browser knows how to validate the certificate is okay and everything is good with that. But some users actually turn this certificate validation off in their browser. And there are many reasons for that. Some of them is because they receiving surfing errors, or maybe because they need to access incorrectly sign their website from time to time, like web developers. And seriously, please don't do that. Try to find another solution. When you do that, you expose yourself to risk, and that could be really a big problem. And we actually made the POC. which we created a self-signed certificate for our servers, and actually we started to get requests, and some of the requests sent with the authorization token in it, and it was really cool. This was actually a token from an external organization, which nothing to do with us. It was really, really nice to see this. And by that, we actually demonstrated that this attack is real, and you guys should not turn off the certificate validation function. All right, so let's talk a bit about the fix. So Microsoft fixed this issue on September 6th, 2019. And Microsoft decided to fix this issue by adding a simple thing. They created a new A tag element, then set the href attribute to the past parameter. This change actually fixed the problem with the help of the way that the browser handles relative paths. The browser takes the URL as a relative URL, of course, and therefore the browser adds the current host to it. So it's actually solved this problem, because now it's a valid URL and not longer just a relative one. Not to say Microsoft managed to fix this issue before we had a chance to report it to them. We found it like 4 or 5 days before Microsoft, or I think 1 week before Microsoft fixed this vulnerability. And actually, it was really cool to see this. All right, so let's wrap it up. This was the first part of the session. We had the weird telemetry request to a local server. Those telemetry requests contain the user's access token in the authorization header. The request eventually ended up in the attacker's end. And if the token ended up in the attacker's end, it will be able to impersonate the victim and take action on his behalf in the Azure environment. The attacker could create in virtual machines, deleting data, accessing data, and actually do much more than that. So my main takeaway, at least from this vulnerability finding, is always to investigate and go deeper into things, especially when they seem odd, like the weird request we saw. I'm sure that there are many more vulnerabilities like this out there on other platforms, and just waiting for you to find them. All right, so that was the first part of the session. Now we'll talk about the second one. We will cover even more dangerous account takeover vulnerability that exposed all 365 users and AAD users. The vulnerability, which we called it Black Direct, is an auth-related vulnerability. So in order to understand the vulnerability itself, we first need to briefly understand what auth and OIDC are. So let's go over it. So what is auth? Let's answer this question first. Auth is an open standard for authorization, which sometimes it mixes up with its extension, OIDC, which is the Open ID Connect, which is actually extends the protocol to also support authentication. Auth supports authorization, and OIDC extends it to support also authentication. So in short, auth is used to delegate permission of the user's account to first and third party applications. In order to understand why we would need such a thing, we need to first go back in time. So let's talk a bit history. In the past, in order to let a third party application access to your data, you needed to provide your password. Well, what do you think about that? What could actually go wrong with doing this? Well, everything can go wrong, in short. App stores the user's password in plain text. Apps get complete access to the user's account. Users can't revoke the app access to their account except by changing their password. And also, if the application got compromised, it exposed all its users' password. So should we make something different? Absolutely. There were efforts to implement new methods similar to auth before auth was released, but every implementation was slightly different from the other and not compatible with each other. We had Flickr off, we had off sub, which was a Google implementation. We had a BB off of Yahoo, and we had really much more. All of those companies and others joined together and brought up to life auth protocol, the authorization protocol that provides everything that you needed in order to give third-party and first-party application access to your account securely without giving the password. All right, so let's see how it looks in real life. So as you can see, there is a user that wants to get access to office.com. The user browses to office.com and then clicks on the login button. You're redirected to the Microsoft authorization server. The authorization server receives a request with the relevant parameters, like the client ID, which represents the application that asks the user's permission. It also includes the resources that the application wants to get access to, and the redirect URI parameter, which states where the token should be transferred. The authorization server validates that everything is okay. He validates that the user is logged in, the application is authorized by the user, the redirect URI is in the allow list, and etc. After all those checks, the authorization server creates a token. And actually, after it creates a token, the token will be sent back to the office.com server by the user's browser, and then the application can use this token to get the user's data. So that's the flow in general, and every auth application needs to be registered in the authorization server in some way, and also it needs to be approved by the user. So if we take Microsoft, for example, in Azure, every application is represented as a service principal object, which is an instance of application object. The service principal looks like this, in this image that you can see. You can see a JSON object that represents the application settings that include the application name, application ID, and also includes authorized list of URLs that can receive the generated tokens in the future. In this example, you can see that the allowed URLs in this case is google.com and google.com/a/anything that will come after it. So far so good. It sounds like nothing can go wrong here. Well, almost nothing can go wrong. We found out there are some pre-install service principal by Microsoft in every Azure AD environment, which includes also 365 users. When I say pre-installed, I mean that the user doesn't need to approve those applications manually because they're already approved. Those auth applications are considered privileged because they can ask the users for accessing highly sensitive APIs, like the Graph API, which lets you make changes in the Azure Active Directory, and to the Azure Resource Manager API, which lets you control Azure resources, your cloud assets. So we looked for those pre-installed service principals for finding any kind of bug that can be in those applications. So we found out that those applications have very large whitelisted URI list, as we saw before. We check every application to look if we could take it over, actually we could manage to do so. So some of the URI were subdomains that were vulnerable to subdomain takeover, which I will explain in short. Subdomain takeover, it's an attack that makes the subdomain to point on an IP addresses of my choice because of a bad DNS configuration. Actually, we managed to take over some of the whitelisted URIs, and this actually led us to the following attack scenario. So in this example, we see that we took over secureserver.office.com, and in some way, and this one is whitelisted in the Office application, which is approved by default in Microsoft auth application. That's just an example. It's not, it wasn't that one, but yeah, so you do understand that. So the user clicks on the link or some way browsers to this secure server office.com, which is a trusted one. You can see it's called with office.com, and everything should be fine. The user is actually browser to it, secure.com. The bad server redirects the user to the authorization server. The authorization server validates the request parameters. And the authorization server recognizes that the redirect URI is whitelisted and everything else is okay. And therefore it creates an access token that eventually the victim browsers send the access token to the malicious website, which is controlled by the attacker. And then the attacker can actually steal every data that the users add, change data, compromise things, can do a lot of bad things. So let's see how it actually looked in real life. So this is the proof of concept that we made of this vulnerability. As you can see, this is the victim user. It doesn't actually have any third-party application installed that has access to its account. So it's only the very built-in auth application that's configured by Microsoft. Okay. We'll search for an attacker user that might be exist in the Active Directory. So there is no such a user, of course. Then the user's going to Outlook. He receives a new email. Actually, it's a social engineering email. He receives a new phishing mail from a generic financial company, and he clicks on the link. And actually, when you see this screen, the attacker already have the access token in it. Already stole the access token. This takes only a second, so the users won't actually feel anything and see anything, and will actually after it will redirect it to innocent website that you won't suspicious anything. So it won't look suspicious. And in the meanwhile, we created a new user, which is the attacker. Attacker created a user for him with the highly permissions of a global administrator. So as you can see, a new user created. And let's see the assigned roles and global administrator. That's kind of cool. So that is a really dangerous vulnerability that was closed. So let's talk about the fix. So we reported this vulnerability to Microsoft, and together we managed to fix this vulnerability. It took a while because it's not that easy to fix. There are a lot of applications that you need to monitor and look for those kind of bad URIs that could be taken over. And actually, Microsoft removed the vulnerable URLs from the redirect URI list of those applications, which basically fix the issue for their application. But I must say, there might be more vulnerable application, which not created by Microsoft, that might be in your account and might expose you to similar vulnerability like this. So in order to find those applications and mitigate the risk, we created a free online tool that you can scan your environment with it. It will tell you which applications are vulnerable to similar attack in your account. So let's talk a bit about the statistics. We ran more than 200 scans, and the tool detected more than 1,200 vulnerable URLs in 700 different auth applications. In addition, we found, with the help of this tool, of course, another 4 Microsoft vulnerable applications, and we reported it to them, of course, to Microsoft. So if you want to see if your environment might be exposed to such risk, you're more than welcome to run this tool in the website Black Direct. You're more than welcome to do so. So guys, that's it. I was Omer Tsafarti. I hope you enjoyed the session. And if you would like to read more about those vulnerabilities, you can check our blog posts on CyberArk Labs website. Links are shown on the screen. So thank you for your attention. Let's get back to the studio.